Our country is no stranger to crisis. From natural disasters to social and political turbulence, the Philippines consistently ranks among the riskiest countries in the world. In the recent years, we were subjected to a major crisis with the spread of COVID-19. And then, as if one humanitarian crisis was not enough, it was also during the spread of the virus when typhoons, volcanic eruptions, and other natural calamities wreaked havoc on the country. But there is one sector that bears the brunt of these crises the most. Considered the backbone of our society, the agriculture sector responds to our public health needs by ensuring food security for every Filipino. Yet despite their crucial role, Filipino agricultural workers remain among the poorest, most disadvantaged groups in our society. Maintaining a healthy quality soil is crucial for the foundation of profitable, productive, and environmentally sound agricultural systems. Testing the soil is more important than ever because of changes in crop and fertilizer prices. On another aspect, in the farming process, often used conventional seeding operations take more time and more labor. So as long as these structural barriers are dismantled, the common Filipinos will continue to suffer. Thus, the researcher is driven to make an automated seed sowing device that comes with an NPK-based sensor for real-time monitoring of soil nutrients. This is to aid the farmers in making their work faster and lessening their time and labor consumption in farming, and to keep track of the soil's nutrients for a better yield of crop production. This is Eunice Austero saying, with major problems, we're stronger with joint forces.
We AgriGate, automated seed sowing device with NPK-based soil nutrient monitoring system.
The general objective of the study is to create an automated seed sowing device that can monitor soil nutrients in agricultural fields and specifically seeks to answer the following questions. To what extent does the AgriGate function in terms of seed sowing feature, soil nutrient monitoring system, agricultural terrain rover, and remote control navigation feature? To what extent does the AgriGate function in terms of the precision of NPK sensor? How effective is the AgriGate device in terms of seed sowing at different types of soil and monitoring the soil nutrients level? And how acceptable is AgriGate to the respondents in terms of performance and user-friendliness? The researchers then hypothesized that there is no significant effect in creating an automated seed sowing device with NPK-based soil nutrient monitoring system. This study would be beneficial to the Department of Science and Technology, Department of Agriculture, Economy, farmers, and future researchers.
To test the hypothesis, let's move on to our methodology. The researcher will first start by gathering all the materials needed for the creation of the agricultural device. For the soil nutrient monitoring system, the researcher will first connect the NPK sensor to the RS485 interface module and Arduino Nano. After that is the connection of the OLED display to the same board. Then, the researchers will prepare the sketch codes to the Arduino IDE software to be uploaded in the microcontroller. For the seed sowing system, the researcher will connect a DC motor to a 6-volt battery. A scoop wheel interconnected with a DC motor shaft will be fixed to a wheel inside the seed container. When the DC motor rotates at a constant speed in a semi-clockwise direction, the dispensing wheel will scoop seeds into the funnel and will pass through a tube. It will then be dropped onto the soil. This is in sync with the flow located under the casing that is responsible for flowing the soil just before the seeds are dropped by the dispensing unit. Afterwards, these two systems will be fastened at the chassis with the use of screws, cable ties, and appendages. Then, the researchers will conduct calibration and test run to ensure its working state and operation flow. The researcher will then test the functionality of the features and sensors of the device, its effectivity in seed sowing, and in monitoring the NPK levels of the soil. Lastly, the researcher will conduct survey to the respondents to determine its acceptability. After the experiment and the survey, all the data will be collected, analyzed, and treated with statistical tool.
Together, we are stronger. Collectively, we can do much change. This is AgriGate, the future of agriculture.